Okay, guys, so today we are going to be talking about imaginary numbers. This is something that is completely new. You've never learned this at any time in math, so it's going to be a new concept for you. So we want to be able to define and use the imaginary unit I. I is what we use to represent an imaginary number. We want to be able to perform operations with complex numbers. Complex numbers are these numbers that have a real part and an imaginary part. And we want to be able to find complex solutions and zeros. All right, so what is an imaginary unit? Well, when we take the square root of -1, normally we would say you can't even do that because there's no number times itself that gives us -1. Mathematicians didn't like that. So what they did was they developed this imaginary unit called I. Up to now, every answer you have found has been a real number. The only other type of number there is besides a real number is an imaginary number. And these you have never seen. Like I said, these are numbers that have eyes in them. Sometimes people get confused though about what a real number can be. It can be a whole number. It can be a fraction, a decimal, a radical, pi. Okay. It can be radical 7. All of those are real numbers. The only numbers that are imaginary are those with eyes in them. Okay. So one or the other. A complex number is a type of real number where imaginary number. Sorry, that's a big mistake there. Complex number is an imaginary number that has a real part and an imaginary part. So an imaginary number could be 2 plus 4i. That's an imaginary number because it has an I in it. And in fact, this would be called a complex imaginary number because it has a real part and an imaginary part. An imaginary number, like I said, it can be complex, like I just talked about, or it can be a pure imaginary number. This happens if A is 0. So we don't have a real part. We just have an imaginary part. So if I get rid of this 2 and I just say 4i, that's going to be called a pure imaginary number. It's not complex because it doesn't have the real part and the imaginary part. It just has the imaginary part. Okay, so that's just some vocab. All right, coming down here now. How do we work with this? Well, before, if you had the square root of -3, you would say that has no meaning to us. But now we're going to think of it differently. When I have the square root of -3, I'm going to think of it as the square root of -1 times 3. The square root of -1, we're now going to call I. And the square root of 3, we can't do. So the way we simplify this now is we're going to call this I radical 3. If I want to square I radical 3, if this is what I start with and I want to square it, I would have to say it's going to be I squared times 3. Why do you think I squared is -1? Let me show you why. By definition, the square root of -1 is I. If I square a radical, the radical just goes away. So if I square this, then the radical just goes away and I get -1. So I squared is going to be -1. And that's something you just have to know. You might want to write that down and put a star by it. We're going to be using that over and over, that I squared is equal to -1. The reason why is if I square something, the radical goes away. So I squared is -1. Okay. All right. Let's look at some examples here. I want to simplify the square root of -9. If you don't have your calculator out, get it out, please. If I'm doing the square root of -9, here's the way I want to think of this. I always want to see if I have a negative under the radical. If I do, I want to think of this as -1 times 9. What did I just say the square root of -1 is?
Minus.
I, just I. What's the square root of 9?
3.
So what is this answer? And we're going to put the 3 first and then the I. If we have a radical, we put the I first. But if we have a non-radical number, we put the I second. Go to your calculator. So that we're all doing this the same, I want you to go under mode right here by the second key, go to mode. And I want you to go down here where it says real. Right now, yours probably is highlighted on real. I want you to go over to A plus BI and push enter. I want that to be highlighted. That's going to allow us to work with imaginary numbers. I don't care about anything else. Just make sure you have that highlighted. Go second, quit. Type in the square root of -9. See how it tells us the answer is 3i? Okay. The calculator understands imaginary numbers. Did anyone not get 3i? Good. All right, let's look at this one. Let's do it on our calculator first. I want you and then I want you to think about why the answer is the way it is. Type in 3 radical negative, not minus, but negative 25 and push enter. It's 15i. But this question wouldn't be on the calculator part. It'd be non-calculator. Can you see why this answer was 15i? Sam, you want to explain?
The in the radical would be I, like,
It'd be
-1 times 25. So then there's 3 times 25, or times 5 times I.
Yep, that's it. That's the reason why it works that way. We have to rewrite -25 as -1 times 25. The square root of -1 is I. The square root of 25 is 5, so that's 15i. I can see people don't like this. I see confusion. Guys, all you have to remember is the square root of -1 is I. You just got to get that into your brain. If you forget it, type it in. The square root of -1. What is that? I. Okay, it's just like a fact we have to know. All right, now we're going to look at a pattern for imaginary numbers. We said the square root of -1 is I. What would I squared be? We talked about this a minute ago. -1. Now, we want to know what I cubed is. Well, I cubed is the same thing as I squared times I to the first. Remember how if your bases are alike, you add the exponents? So what is I squared? So I would now have -1. I to the first is just I. So what is I cubed? Just -1i. So I can just call it -I. If you don't know that, type it in. Here's where the I key is. Do you see it down here by the decimal point? Right there's the I key. Type in second decimal to get I, and then right here's the caret to raise it to the third power and push enter. I to the third is -I. Okay? I to the fourth. Well, I to the fourth would be I squared times I squared. What did we say I squared is? So it's -1 times -1. What's -1 times -1? +1. All right, we're going to do I to the fifth. I to the fifth is going to be I to the fourth times I to the first. Well, what's I to the fourth?
1.
Times I. So what's I to the fifth going to be? Just I. Look at the pattern. We start with I. What do you think I to the sixth is going to be then? -1. because it's going to be I to the fourth times I to the second. So it's going to be I to the fourth times I to the second is 1 times -1 is -1. What's I to the seventh? Keep the pattern going. I, -1, -I. What's I to the eighth? Nope. 1. Can you think of now what I to the ninth would be without a calculator? Nope. I. What's I to the 10th? -1. What is I to the 100th?
Uh,
1. How'd you get that? Somebody, I heard at least 4 people say 1. Sam?
no, last,
Right. Isn't it true that every fourth one of these ends up being 1? Let's keep going with this pattern here so you can see it. What's I to the 11th? -I. What's I to the 12th? 1. See how every fourth one ends up being 1? If you have to do I to the 100th, you could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 100. I really don't want to do that though. So anything, any exponent that is a multiple of 4 is going to have an answer of 1. So I to the 100th has to be 1. Where would be the next time that I would get 1 after 100? I to the 104. Can you think of what I to the 101 would be the same as? I. Okay, you guys are doing great. I'm going to have you do 3 on your own now. What is I to the 11th? No, we already did that. Never mind. I to the 81st, I to the 73rd, and I to the 43rd. Let's do those 3. Without a calculator, see if you can figure it out. All right, who knows I to the 81st? Raise your hand. Need somebody new. Okay, what do we have, Sydney? What do you think? You think 1? Why do you think 1? You think it's I? Why do you think it's I? Right. So we know this is the same thing as I to the 80th times I to the first. Isn't 80 divisible by 4? So therefore, this is going to have to be 1 past that. So it's going to have to be just I to the first, which is I. That's right. Anybody know I to the 73rd? That's a tough problem. What do you think, Vaishnavi? You think that's also I? Did anyone else get also I? Yes, that is correct. That is also I. And that's because 72 is a multiple of 4. 72 is a multiple of 4. So it's I to the 72 times I to the first. That's also I. Anyone know I to the 43rd? This one is not I, I'll tell you. Rachel? I got negative I. Did anyone else get negative I? Let me show you how I think of that. I'm just going to explain it. I know I to the 44th is 1, right? So I just think what goes before the 1? Negative I. You might have thought of it a little bit differently, but that's how we do it. Great job with that, guys. I know that's completely new and a little confusing. All right, so now we're going to do something easier. Give our brains a little break here. This is just going to be adding complex numbers. Your calculator knows how to do this, but I want you to be able to do it without. All you have to do is add the parts that are alike. This is a real part. This is a real part. Add the real parts. This is an imaginary part. This is an imaginary part. Add the imaginary parts. Very simple. Okay? Here we are subtracting. What do you have to do when you're subtracting? Distribute the negative. I personally like to, when I have subtraction, I like to keep the first one the same. And then I distribute this through. So it's going to become -2 and plus 3i. And now combine your like terms. Junior, can you tell me?
I cannot.
Yes, you can.
I cannot. I'm very bad at it.
Oh, okay, recover. You ready now?
No.
Come on. The real parts. Add these real parts. What do you get?
-5.
You got it. Add these imaginary parts.
Oh, sorry. Um, I guess
4 plus 3.
oh, 7.
7i. There we go. You are a winner. Okay, that's how we add or subtract imaginary numbers. Okay? What are we doing here? Are we adding or subtracting? Either one. We are. How do we multiply binomials? Spoil it out. Yes. So we're going to have to multiply these two together. We get -6. Multiply these two together. We get positive 9i. Multiply these two together. We get positive 8i. Multiply these two together. What do we get on those?
Well,
Negative 12i to the second. All right. The reason I made you do all that work just a minute ago that really strained our brains trying to think of I to the 99th or whatever we did, that's because we're never going to leave an exponent on an I because it can always be simplified. Does anyone remember what I squared was? -1. Very good. So I'm going to rewrite this. I'm going to add these two. And we just said I squared is -1. So that is actually going to be a plus 12. So I have -6 plus 17i plus 12. And so I'm going to get 6 plus 17i. Okay, you could put that into your calculator. It can do multiplication with complex numbers. All right, guys. I want you to practice this a little bit. I'm going to give you 10 seconds, and I want you to try the first two very quickly. All right, time's up. Ramney, can you tell me number 1? 7i, good job. And number 2, Ruthvik, can you tell me? You got it. Easy as can be on those because these are perfect square roots. Let's do one that's not quite as easy. So I'm going to have to think of this as -1 times 9 times 5. I chose the 9 because it's a perfect root. What is the square root of 9? What's the square root of -1? Here's the order we write it in. We do the real part, we put the imaginary, and then we put the radical. We don't put the I at the end because then it looks like it's under the radical and it's confusing. So we do real, imaginary, radical. Okay? All right, 10 seconds. Do numbers 4 and 5 on your own. 4 and 5 on your own. Give you 20 seconds. All right, who has number 4? Let's go with you, Ethan. What'd you get? -20i. Does anyone agree with him? Good, because he's right. Okay, how about number 5? Who has that one willing to share? All right, Sam, what do you have? 66i. Agree? Here's how we do it. We have 6. We have -1 times 121. What's the square root of 121? 11. What's the square root of -1? That's our new one, 66i. Okay, he is right. Number 6. How are we going to break this apart? What numbers multiply to be 75? And I want 1 to be a perfect square root. What's it going to be, Miriam? Good. So I have 25 times 3 times -1 is equivalent to that. So what do we have? We have 5 on the outside. We can do that. That's 5 on the outside. We can do that. That's I on the outside. So our answer should be 25i radical 3. Okay? All right, ACT prep kind of question. They give you something you've never really seen before, and they ask you to find the value of x plus y. So they're asking us really to find x and to find y, and then to add them. Does anybody have any idea on how we could start this? This is a complex number, and this is a complex number. We want the real parts to be the same, and we want the imaginary parts to be the same. Does that help on how we could start it? What do you think, Sydney? Hmm. Okay, interesting. So she's kind of wanting to get the eyes together and the real parts together. Actually, that's not going to be the easiest way to do it, though. See, here's what we have to do. We have a plus bi equal to a plus bi. We want this to be equal to this, and we want that to be equal to that. So there's a little bit of a faster way of doing that. What do you think we should do if we want these parts to be the same? What's my equation then? Negative 10x, what does negative 10x have to equal? What's our real part over on the other side? 30. What's our imaginary part on the left side? Whoops, sorry, I scrolled the wrong one. What's our imaginary over here? So I want 4i to equal negative yi. So now do you know what x would have to be? Good. And do you know what y would have to be? Negative 4. And so now we can answer the question, what's x plus y? Negative 7. Okay? So we wanted to set the real parts equal, imaginary parts equal, and then go from there. Okay. I would like for everyone to try numbers 9 and 11. If you get stuck, I will be working them up here, but I want you to try it on your own. Should be about finished with number 9. Check your answer before you go on to 11. And before you start number 11, I want to tell you the worst thing that you can possibly do that will upset me. Do not just square this 4 and square this 3i. That's a common mistake, but we cannot do that, you guys. If this had been multiplication, Then we could just square them. But if it's addition or subtraction, what do we have to do on this one? Foil it. You have to write it twice and you have to multiply it out. You have to distribute all the way through. How'd you do? Did you get both of them right? Awesome. Now up here it also said, Rachel?
Have to put the constant first.
Yes, and that's because the definition of an imaginary number is a plus bi when it's complex. We want real and then imaginary. Now, the second part of this says if the result is an imaginary number, specify if it's a pure imaginary. Are these pure imaginaries? No. Let's find one that is. What about this one? If I add the real part, what do I get? Then what do I get on the next part? That's what we mean by a pure imaginary. These would just be regular old imaginaries, which can also be called complex. It means the same thing. Imaginary, imaginary, pure imaginary. Okay? I want to pause there for a minute just to kind of give your brains a break.